We're going to find derivatives of functions at a given number. It is the exact same thing we did when we were finding the tangent, slope of a tangent line. So basically it's a new concept. This is going to be helpful in physics, finding instantaneous rate of change, in calculus, by the way, and instantaneous speed of a particle, and other word problems that you might run across, to application problems. The application problems will come next if I don't do another video on this one. So I'm going to start out with the easy derivatives, and then if I have time on the video, I'll get into the harder ones. If not, I'll make another video with the harder ones. So basically all you're going to do here, and just recall that this looks just like the slope of the tangent line formula, which it is. We're finding a limit. The limit is the slope, remember. So we're calling this now the derivative of f at c. It's also read as f prime of c. So depending on your teacher, it depends on how they say it. I usually say the derivative of f at c, and a lot of teachers say f prime of c. All right, so the first one we're going to do is f of x equals negative 4x plus 5, and at c. Remember, our c is our x on the graph. So as x approaches c. So what we're going to do is we're going to take the derivative of 3. And again, let me go back. We say the derivative of f at 3. So we'll say the derivative of f at 3 equals the limit as x approaches 3. And then I just do the same formula I did with the tangent line for x minus 3. Here you just copy down your formula. So that's the limit as x approaches 3 of negative 4x plus 5 minus whatever your f of 3 is. Now your f of 3, I'm going to copy that down, is you just plug in 3 here and you get negative 4 times 3 plus 5, and that's going to equal 7, negative 7. So you get negative 7 here. So basically, clean the numerator up a bit. You get negative 4x, and this is going to be positive, so you can get plus 12 over x minus 3. I'm going to factor out a negative 4 and get x minus 3 here. You cancel these two out. So the limit, or the derivative of f at 3 is going to be negative 4. And that's all you do. So if you did the tangent problems, this should be fairly easy. So we're going to go a little faster here. Let's do quadratic. We're going to do f of x equals x squared minus 3 at 0. So that's our c, at our c. So the derivative of f at 0 equals f of x minus f of 0 over x minus 0. So that yields x squared minus 3. I'm going to plug in 0, and I'm going to get another negative 3. So minus a negative 3 all over x. So that's just going to give us x squared over x, because this is plus, so that cancels. And when you reduce that, you just get x. So the derivative of f at 0 of x will equal 0. And basically we're saying the limit as x approaches 0 of x is 0, because you're plugging that in. And that equals your f derivative, the derivative of f at 0. Okay? let's do another quadratic. So we have f of x equals 2x squared plus 1 at negative 1. So f prime of negative 1 equals f of x, and we're going to take, let's write the limit in. The limit as x approaches negative 1, f of x minus f of negative 1 over x plus 1 minus the negative 1. I'll write that in. Okay, so that gives us the limit as x approaches negative 1 of 2x squared plus 1 minus 3 over x plus 1, which is going to be 2x squared plus 4 over x plus 1. So that's the limit as x approaches negative 1. And I'm going to factor out a 2. And you get, this is a minus 3. So this should have been here. We should have had minus 2 plus 2. So it's minus 2. Yeah, it's minus 2. Okay, factor out a 2. We get x squared minus 1 over x plus 1. I'm going to factor out the numerator. And you get x minus 1 times x plus 1 over x plus 1. Crosses out. And then you plug in negative 1, so you get 2 times negative 1 minus 1. And that's going to yield negative 4. So basically the limit as x approaches negative 1 equals negative 4. All right. Let's see. Let's do another one. F of x equals 3x squared minus 4x. And we're going to take the derivative at 2. So f prime of 2 equals the limit as x approaches 2 of our f of x minus f of 2 over x minus 2. So that's going to give us, doing this one, that's going to give us the limit as x approaches 2 of 3x squared minus 4x minus 4. All I did was plug the 2 in. You're going to have to plug the 2 in, and then you're going to get 3 times 2 squared minus 4 times 2. And you do this little bit here. Okay, this is all over x minus 2. I'm going to factor the numerator. Again, we're trying to get rid of this. So the limit as x approaches 2. And when I factor this, I'm going to get 3x plus 2 times x minus 2. And it always helps when you get the problems in the book to, in factoring, you probably are going to have this in your factor. Now you plug in 2, and so that's going to be 3 times 2 plus 2, which equals 8. So that's your derivative of f at 2. All right, let's do a cubic one. We have f of x equals x cubed plus 4x. And we're going to do at negative 1. So the derivative of f at negative 1 equals the limit as x approaches negative 1 of f of x minus f of negative 1 over x. I'm going to go ahead and put plus 1. Because x minus a negative. All right. So what we're going to get is the limit as x approaches negative 1 of x cubed plus 4x plus 5 over x plus 1. Now, what I'm going to do here is this is just not helping me. I can't factor this in here. So I'm going to do a little algebra trick. What I'm going to do is take the limit. I'm going to break this 5 down and write it as x cubed minus 1. I'm going to do plus 1 plus 4x plus 4. Do you see what I did? I put the 1 here because what I want to do is factor by grouping. And I know my formula for the sum and difference of cubes. And you should know that. If not, I have a video on that. But this is the form of a cubed plus b cubed. Most of y'all learned it in Algebra 2. So this is going to be x plus 1 times x squared minus x plus 1. I'm going to factor out a 4. I'm going to get x plus 1. And I wanted to write it as a 4, but x plus 1. Now, when you factor, we're going to put these two together and these two. You could put the 4 at the end. So basically, this equals the limit as x approaches negative 1 of, I'm going to put these two together first, since these are the same. So this is going to be, let me do a different color, x squared minus x plus 1 plus 4 times x plus 1. And instead of writing this out, this is going to be x squared minus x plus 5 times x plus 1. We did this in a previous video with the tangent line, and this is all over x plus 1. This cancels. You plug in the negative 1, so I'm going to do negative 1 squared minus negative 1 plus 5, and that's going to yield 7. So the limit as x approaches negative 1 of x squared minus x plus 5 equals 7. And there you go. That goes with that. Let's see if there's another one where we have to do the factor by. Here's another one that seems a little difficult. We're going to do f of x equals 2x cubed minus x squared, and we'll find the derivative at 2. So the derivative of f at 2 equals the limit as x approaches 2 of f of x minus f of 2 over x minus 2. So this equals the limit as x approaches 2, and we're going to copy down 2x cubed minus x squared. That's my f of x. And minus f of 2, I plug in 2 here. And when I plug in that, I'm going to get 12. So it's going to be minus 12. I just plugged in 2 here. All right, all over x minus 2. Now, what I'm going to do is write this as the limit as x approaches 2 of 2x cubed minus 4x squared plus 3x squared minus 12. Now, what did I do? I want to factor by grouping. I have to get rid of this, or I can't find the limit. So I took this guy and split him up. Oh, this is supposed to be squared, sorry. I split him up so I could group this. And when you group, you're going to get 2x cubed minus 4x squared, grouping that together with 3x squared minus 12. Now I'm going to factor out 2x squared and get x minus 2. Then I'm going to factor out a 3 and get x squared minus 4. All right? So then this part's really going to be 3 times x minus 2 times x plus 2. So please have this written down because I'm going to go to the next page. And you notice we have 2 of these. So basically what I'm going to do on the next page is group this way. I'm going to do x minus 2 times 2x squared plus 3x plus 6 over x minus 2. And again, this is the limit as x approaches 2. Then these will cancel out, and you just plug in the 2. So I'm going to kind of plug in the 2 in my little cloud here. And when you do that, you get 20. So the limit as x approaches 2 of 2x squared plus 3x plus 6 equals 2. So, or 20, sorry. So that's how you do these problems here. Okay? All right. The next video I'm going to be making is word problems involving the instantaneous rate of change and the instantaneous speed of a particle.